Good afternoon.
Good afternoon, sir.
Good afternoon, sir.
और सब कहाँ गए? Okay. So today basically we are coming to discuss about finite difference method. Okay. Anybody can say what is the meaning of finite difference method? Sonalata?
Yes, sir.
Can you say about the finite difference method?
No, sir.
So just we have to discuss about the finite difference method. But in this method, the derivatives appearing in the differential equations and the boundary conditions are replaced by their difference approximations, and the resulting linear system of equations are solved by any standard procedure. These roots are the values are required to the solution of the pivot points. So actually that is concept. Concept क्या है? What is the finite difference method? Finite difference method basically क्या है? A finite difference method, which is this is standard from a finite difference method. Just see finite
sir.
difference method. Hello.
Sir, please share the screen.
A screen has not shared. Okay, just a minute. Finite difference method. Just you see finite. This is a finite difference method. Finite difference method I have to discuss. Finite difference method. In this method, the derivatives appearing in the differential equations. In this procedure, derivatives appears in the differential equation. Just you see. Derivatives appear in the differential form. Derivative appears in the differential form. Differential equations form. And boundary conditions are replaced by their difference approximations. Only condition in boundary conditions. A differential equations means that is represented as the dy by dx, d square y by dx square. These are like this procedure you have to follow. The finite difference method basically appears in the differential equations. Second case. What is the second case? The second case is that derivative appears in the finite form and boundary value problem or boundary conditions. Boundary conditions are replaced by boundary conditions. Conditions are replaced by finite difference approximations. Finite difference approximations. Just you see. So what is the finite difference scheme? Now, finite difference scheme basically including the one is differential equations must be is there and boundary conditions also must be is there. We have already discussed in previous class about the boundary conditions. And just boundary conditions, that means y of x0 which is equal to a and y of x a which is equal to b, x1 that is going to be. This one is the boundary conditions. The finite difference approximations to the various derivatives are we consider as the following procedures. Just one example we have to take here. So what is the example? See, yx plus h. Suppose one function y is given and that is written x plus h. And by using the Taylor series expansion, we expand it. And Taylor series say that y of x plus h into y dash x plus x square by 2 factorial into y double dash x plus h cube by 3 factorial y triple dash x and so on like this. Taylor series says that this is you apply Taylor series method. Here application of Taylor series method and to produce this expansion yx minus h that is equal to yx plus minus h y dash x plus h square by 2 factorial y double dash x minus h cube by 3 factorial y triple dash x plus and so on. Just you look out yx plus h and yx minus h. This equations, suppose you naming this equation 1 and this equation 2. Name this equation 1 and 2. Whenever derivative of the equation 1 and equation 2, what is the result? Yx plus h, yx minus h is there. See that one? Y dash x is equal to yx plus x minus of y of x. See this equation? Just equation 1 you choose. From equation 1. Y of x plus x minus of y of x, that is equal to x y dash of x plus h square by 2 factorial y double dash x plus Just we have to consider y dash x and remaining value as consider the error part. Then what is the value? Y dash x becomes y dash of x is equal to 1 by h. This value y of x plus h minus of y of x plus minus order of h plus order of h. कुछ error value यहाँ पे आएगा तो higher order को हम remaining छोड़ दिए, omitted किए हैं, left it. So y dash x can be represented like this form: yx plus s minus of yx, that is the y dash of x. Similarly, we can calculate from equation 2 also. Use equation 2. What is equation 2? From equation 2. Yx minus h minus of yx. Yx minus h just you see yx minus of yx minus x by h is equal to y dash x. So from 2 also another derivative part of y you can found here, and that value becomes 1 by h and y of x minus of y of x minus of h. And that is plus order of h. The remaining part is there. Which is the backward difference approximation y dash x, and error of the h is the error part. Or from equation 2 subtracting from 2 and 1, or otherwise हम ऐसे भी कर सकते हैं, ये 2 इसको subtract कर देते हैं, 2 minus 1. 2 minus of 1, that means yx plus h minus of 1 minus of 2. Yx plus h minus of yx minus h is equal to, this is 0 and 2h y dash x and order of h square. When we subtract equation 1 and 2, subtract equation 1 and 2. Just will come and subtract equation 1 and 2. Subtract equation 1 and 2. One and 2. Then the value y dash of x, which value becomes 1 by of 2x, yx plus h minus of yx minus of h plus order of h square. Which is the central difference approximation method. This procedure is called central difference approximation method. ये मेथड जो प्रोड्यूस हुआ है इसको हम कहते हैं सेंट्रल डिफरेंस मेथड. सेंट्रल difference method. ये जो मेथड प्रोड्यूस करते हैं that is central difference method or approximation of y dash with an error of order of x square, and this is called as the error. This is error of this function. Clearly, the central difference approximation y dash x is better than the forward and backward difference approximation method. So y double dash x कैसे निकालेंगे? Now that is the same process by using the central difference method. Y double dash x also can be calculated, and that process is equal to 1 by of h square y of x plus of h minus 2 y of x plus yx minus h. This is forward difference and this is backward difference and order of h square. That is the double derivative result. That is also central difference method. Hence, working expression for central difference approximation of the first derivatives of yi are as under below. So working procedure क्या हुआ? What is your working procedure for finite difference scheme? So just we look out the working procedure by the finite difference scheme. वर्किंग प्रोसीजर हम लिखेंगे. वर्किंग प्रोसीजर क्या है? Now, y I dash is equal to, we can write here 1 by 2h yi plus 1 minus of yi minus 1. This is a central difference procedure. Then double derivative value yi double dash, which is equal to 1 by h square. And this value yi plus 1 minus of 2 yi plus yi minus 1. That is the double derivative of yi double dash. Yi triple dash. Triple dash, which is equal to 1 by 2 h cube. One by 2 h cube, and this value yi plus 2 minus 2 yi plus 1 plus 2 yi minus 1 minus yi minus 2. And so on. This is the finite difference form of first derivative, second derivative, and third derivative. That is the procedure. Just you have look out this formula. Okay. Just we discuss one example. Just everyone see this example. Example. What is the example? Solve the equation. Solve the equation y double less x is equal to x plus y with the boundary conditions y0 is equal to y1 is equal to 0. This one is the one example solved by using the finite difference schemes. तो कैसे हमको सॉल्व करना पड़ेगा ये क्वेश्चन with interval is given here. We subdivide the interval 0 and 1 because boundary condition is 0 and 1 is there. Is subdivided this interval. This is 0 and this is 1. x0, x1, x we can define up to 4 intervals. Consider 4 intervals. Four intervals. Then we arrange h value and that h is equal to 1 by 4 in step size. And pivot points are pivot points. x0 starting point, that is 0. x0 plus 1 by h, that is x1. Another point 1 x1, that is 1 by 4. Then x2 plus 1 by 4. x1 plus 1 by 4, that is 1 by 2. Then this is x2 1 by 2. Next x3 plus 1 by 4, that is 3 by 4. And finally x4 1. So then difference of the equation is approximated. Second order differential equation is given in this problem. So then difference equation is approximated. Difference equation is approximated. Mated. What is the, because second order differential equation gives us 1 by x square yi plus 1 minus 2 yi plus yi minus 1, which is equal to given derivative. This is the second order derivative value, and derivative equation also given here. That is, what is the value? X plus y. That means xi plus of yi. That means this is the value xi plus of yi. Everyone see this? If have you any doubt from your side, then you can reply to me. Then yi also is there. Yi inside also there. But in the conditions at the initial stage, y0 and y4 becomes 0. So put the value of h. One by put the value of h, and that h value is equal to 1 by 4, and 1 by 4 means 1 by 16 squares. That means 4 square means 16. That is 16 of yi plus 1 minus 32 yi plus 16 yi minus 1. Which is equal to xi plus of yi. Then this value is reduced to 16 yi plus 1 minus of 33 yi plus 16 yi minus 1, which is equal to xi. See, I is running from 1, 2, 3 only. So, according to boundary condition, just you see, according to boundary condition or BC, y0 is equal to y4 is equal to 0. So that we get the system of equations. So that we get the system of equations. System of equations. Just you see. So that we get the system of equations. What are the system of equation? Just put I is equal to 1. Then 16y2 minus 33y1 plus 16y0 is equal to x of 1. And that is equal to 1 by 4. First equation is reduced here. Second equation, put I is equal to 2. 16y3 minus 33y2 plus 16y1 is equal to x2. That is equal to 1 by 2. Again 3. 33. This is 16y4 minus 33y3 plus 16y2, which is equal to x3. That is equal to 3 by 4. But in this condition, you look out here, y0 and y4, that is 0, you substitute. Then you simplify this equation. This equation is simplified by using your calculator. Then you got the solutions of y1, y2, y3. Then you continue this solution, simplify the above equations. सिंप्लीफाई कर सकते हैं? हेलो हेलो,
Yes, sir.
any doubt from your side?
No, sir.
डाउट नहीं है किसी का भी? तो ये जो सिंप्लीफिकेशन करने के बाद हमको एक सॉल्यूशन आएगा, y1 वैल्यू आएगा एंड दैट वैल्यू इज इक्वल टू माइनस 0.303 488. y2 आएगा -0.05632, then y3 -0.05003. This is your final solutions of the above boundary value problems using the finite difference scales. Okay. Have you any doubt from your side?
No, sir.
Okay. So we'll discuss this question also next time. Okay. Another example we have derived the next times. Okay.
Okay, sir.
Okay. So thank you. Thank you to all.
हेलो सर.
Hello.
सर आज के नोट सेंड कर दो प्लीज.
हाँ ये सब अब सेंड कर देते हैं, ठीक है.
यस सर.
ओके, अभी ही सेंड कर देते हैं तुमको.